Okay, so hi everyone. So this is the day 4 for our camp, and today we are going to talk about some basics of statistics. And because for the basic of machine learning is super related to the square regression line, so I'm going to go over this regression line with statistics first. Thank you thank you. And then I'm going over for the part that is about the basic concept of machine learning, and then I'm going over some machine learning algorithm in Python probably. So that's the basic design. So I'm first going to talk some about statistics. So I'm going to use a textbook directly because I feel like it's a direct way of showing things. So the first part I'm going to show is about association. For the other most of this part I will not go over because they are basically about how to read a table and love. You probably already have an idea for that. And also we have talked about pie charts, plot, or histogram. So I'm going to speak about that, but I'm going to talk about association. So what? I think I'm probably search for association. Association is something that's related to yeah, I just saw that part, but it's just oh, so here I'm going to quit the Slack because it's raining. So first we need to know about this concept of association. It's between two variables. If knowing the value of one variable helps predict the value of the other, if knowing the value of one variable does not help you predict the value of the other, there's no association between the variables. And this might sound a little bit basic, but it's important for least square regression line. This is a table that we have been talk about. Here is we can describe the strengths of the association. Describe that by the coefficient of the coefficient, which I'm going to scroll down and show that later. So if the coefficient is close to 1 or close to -1, it means the association is strong. If the coefficient of association is 0, I'm going to admit people. So if the coefficient of the association is 0, that means you don't have association. So the a situation that is no association is basically you have points that is completely random, cannot see any pattern. So that's the coefficient of association is 0. In this statistic book, the association has been described as almost linear because it's described least square linear line. So, and yeah, here's about association. So we have positive association and negative association. This is positive association. If it's really strong, then the coefficient is 1, but if it's in the other side, it's -1. And so basically, if it's from 0 to 0.3 or 0 to negative 0.3, then we say it has a weak association. And if it's between 0.7 to 1, then we will say it has a strong association. And if it's 0.9 to 1, we'll say it has extremely strong association. And something about the linear, so how to describe that is that you are going to describe whether it's positive or negative, and then you need to if it's this kind of association, you need to say that it's a linear association. So first it's positive and negative, then it's linear, and then you will state that it's strong or not strong. So that's 3 parts. So this we can describe that there is a positive linear fairly strong association or relatively strong. This is strong. The not strong one is really abstract sometimes. This is very, very strong. This is also strong. And we have the correlation R. So correlation, that's like the coefficient that we discussed about. So correlation R measures the direction and the strength of the linear relationship of two quantitative data. So here we can see like this correlation is almost like -1. This is really strong. And actually correlation equals to 0.5 is already like a little bit abstract, but you can see like this is positive. It has a correlation. This is like more abstract and does not have a correlation. It's just like completely random. And something that about linear, about like this is like the formula to calculate the correlation R. So it's better like to write with the sum. And basically this is mostly not like calculated by hand. So that's why we need Python or need our calculators, because you have a lot of points and you don't want like just calculate, put each value. And it's really hard to calculate the standard deviation by hand. So that's why like we don't really like calculate in this way. And there's like when we cannot describe them with we cannot describe them with a linear relationship, is that if you just take the regression of them. So basically regression, I need to like find example here. So yeah, here's like the talk about regression line. So you have this point, that's your true data type, and this is a regression line, which I'm going to talk more about that later. So the true value just subtracts the predict value. So the value on the line is the predict value, and the result is the regression. And you just like take all this difference and plot that in a new graph, which you can see like point both on the negative and positive line. If like those points is under this line, then on the regression graph, you have like a negative value. And if it's like those point that is above the line, when you plot the regression graph, those points have like positive value. If that graph does not show like a fan shape or a like polynomial shape, or like a line, not even a linear shape, because you have already taken the regression. So if it show any like shape that is not completely random, then probably taking linear regression is not correct. So probably if we have time today, we're going to go over those like polynomial regression, like plots, or like machine learning plots. So regression line is a line that describes how a response variable y changes as explanatory variable x changes. We often use a regression line to predict the value of y for a value of x. So this is a regression line, which I've just shown. And this is an equation. So we will also use them in like our basic machine learning. So this A is the intercept. Sometimes like people might like represent this with B and this with A. It can be really confusing. But it's like just see the position. It's like easy to understand which is like intercept, which is slope. But just don't like remember A is certainly this intercepts. This is like can change all the time. So don't remember like that. And hat just like this is read as like y hat. It just means like predicted value. So basically means like the value on the line. And if you describe the value that is not on the line, that is our real value, just use y. So regression is just y. Like residue is like what has been remained is residue. So basically like y minus y hat is our residue. And we can read a graph to see. So let me find a graph, like how to see like which is intercept, which is correlation. Do we have the graph here? I don't have that here. It's like in the later part of this book, so I'm probably like read that when we have like see that part. So we go back to see this part. So basically, why like we use like least square regression line? What does least square regression line really means? So what this really means is that like your predicted value minus your real value is a residue, and the square of each residue, we sum them together. That's like we have a value, and we need that value to be as small as possible. So that's the line that we want. But we really remember, like, it's not all like just this point minus this point, but it's like the square of the residue, the sum of the square of the residue is our least square regression line. And this is like this the statistics has find like this is like pretty much accurate for describing our data. And so like how can we predictive value is just if you can like find the slope, you can know the intercept of the predict value of the predict line. And now we have like you want to predict that like in when the Maya has like 70,583. You just put the plug this in plus x in, and then the price like you get here is our predicted value, and the residue is just our real y, the observed y minus the predicted y. So the description is just something is higher or lower than expected, and you need to say the unit. And this sentence is not like necessary to state all the time. It's like just depend on what it's asking. And so we are going to talk about Python, not about like calculators. So yeah, so basically it's just also like similar like when you're programming into like plugging the values in to draw the like least square regression line. And this is our residue plot. So when you like take the regression, when you get the residue, it should be like distributed randomly, as I said before. This is not correct. This is not correct, because you should not use the line to describe it. You should use a polynomial function to describe this. This is like really clearly it's polynomial. Then it's about like how to calculate standard deviation of residues. Mostly we will also not calculate by hand. You have a lot of points. It's really not easy. And this is a coefficient R. So if it's R squared, it means like the variation of the values when you describe R squared. And it's not like, it's like this R square happen to be the square of the coefficients. So when we describe like the coefficients and the coefficient of determination, we don't like describe it similarly. This when we describe like when we have the value of coefficient of determination, we say like this is like the value of y that is predicted is varied by if it's like 0.383, we will say like it's like 83% of varied from the real y value. But for the last one, we will describe like we have a positive linear strong like relationship between blah and blah. So this is describing variation, and the one that we had talked about, the R, is described about like the strengths, although like they are actually related to each other by square or taking the square root. And so like this is a residual plot, and this plot does not have any shape, so we have like as a right model. Yeah, so this is a graph that I'm also like going to talk about. So this is like how to find the intercept and how to find like the variations. So this is an intercept because this is a constant. So constant is like the intercept, and the slope is like this minus driven. this is like, here it has actually been labeled. This is our R square, this is our variation. For the other, we will not use a lot. This is the same. This is just like the intercepts, the slope, and the R square is here. So the two are just basically similar to each other. This is like the slope. This is a y-intercepts. This is the slope, and this is our R square, the coefficient of determination. And this is also like, this is showing the way to calculate the slope. So it's the standard deviation of y over standard deviation of x and times our correlation. And this is a way of like calculating our intercepts. This is actually like kind of useful. So you can see here, we can like see this example. We have like given the standard deviation of x and y. So we can calculate this, and we have given the coefficients, and then we can calculate the slope. And we have our predicted value, and we can like just get the results of the slope timed by our x, so we can actually calculate the slope. So they are all not a great residue plots. This is kind of a great residue plot. So when you see like the residue plot, you will see like the like value above, the value which is positive and the value which is negative should be about equal, or like about like has like the balanced position. Something that is called like outlier influential points. Influential points is also, you can call that a leverage like point. So influential point is like, if you have like this point here, it's really determined that your line should be in this, like being the slope. If it's an outlier, then it's like here, it's like super, doesn't really make sense. It's more like something that you get it wrong, or this is just become like some coincidence. But influential point is the point that actually like enhance this tendency. It's called influential point. Or if it's like far away from like this cluster, we also call it like leverage point, because it's kind of like a leverage. And so association, like I have mentioned before, association and causation is not the same. So probably like it asks like probably like it asks that the like your history, let me think about it. Probably it's like the person who did higher on history also did higher on computer science, and like the performance on history is the x-axis, and the performance for the literature is the y-axis. It's not really like because you do well in literature, thus you do well, or because you do well in history, thus you do well in computer science. It's not. It's like probably like because you are really like devoted in study, you really have the passion for study, so you are both good at literature and history. It's not like because literature and then history. And also it's like when people argue for vegetarian is good or not, some people will argue like vegetarian is good, it's like healthy. Is not like is only the association, it's not the causation. It's because people who become a vegetarian, it's probably those people mostly have a high socioeconomic status. The high socioeconomic status bring people more health wellness. But instead of like vegetarian, like directly contribute to health, like good health. So that's like some arguments. It's just like whether those things are causation or association. But linear least square regression line, that's only for association. So our coefficient is the coefficient of association. So like here that say, like association does not imply causation. Causation is something is a reason and it has result and in something. It's not also like if you like learn statistics course, you usually like face a problem like this. Like it's like you have like some people like it's like usually about health. So some people have like a good like health, and you need to like talk about the confounding variables. The like people like probably test like drink, probably like the example is like drink less coffee means the person more like becoming more fit, but like drink probably like small class. I think the question like small class like promotes like much a good health, and like the confounding variables in those like statistical problems, like because the person smoke less, the person probably like also like care more about health. Probably the person run a lot or like drink a lot of water, just like meditate a lot. That's like the confounding variables for the results. This is like the summary of them. And so this like chapters about these regression line. I'm also like talking about how to like describe those data. So for like describe the data like this histogram, you have like 4 things to describe about if it's about like basic statistics. So the first that you need to describe is its shape. So the shape can be uniform, or the shape can be like, so it's basically uniform or unimodal or symmetric or like skew to the right, skew to the left. So this is skew to the right. How to determine it's skewed to the right or skewed to the left is like, if the tail points to the right, then it's skewed to the right. If the tail points like this is the tail, if the tail point to the left, then it's skewed to the left. If it's like this, like a bell shape that's like roughly symmetric, or like if it's like of uniform height, you can say like it's uniform, but at the same time you can say like it's symmetric. A lot of time in statistics, people use really like precise words, so they will say like approximately symmetric, relatively symmetric, relatively strong, seems to have an association, seem to be an outlier. So we need to be careful with those words. Unimodal basically means like we only like have a peak, so this is a unimodal shape. But if we like it's like this, so like this, then that's like not unimodal. You can say that you have two peaks if it's like this. And the second part is you need to describe about outliers. So outliers, something that you can calculate precisely. It's usually, I have talked about yesterday when we talk about pandas. When you get the panda result, you can get like the 25% of that column. You can get like the 75% value of the column, and you can get the 50%. So I've said like 25% is first quartile, 50% is median or second quartile. We scarcely see second quartile because the median is much more like universally known, and 75% is third quartile. And I've described like yesterday that third quartile minus first quartile is our interquartile range, and the range that is outside of Q1 first quartile minus 1.5 interquartile range, and to like third quartile plus 1.5 interquartile range. Between this is not an outlier. Beyond this, like it's much smaller or much higher than that is our outlier. But sometimes we don't have the precise data, then we are going to say like, because probably we have a value here, we will say like, it seems to have one outlier between blah blah. That seems to have an outlier at the position of blah blah blah, unless you have the like the detailed result. And after S and O, the third is center. You need to describe about median or mean. And sometimes we use median, sometimes we use mean. The reason for use median over mean sometimes is because like the mean is not like resistant to extreme value. So we know like if we have like a value that is really great, if like everyone like the test, for example, like everyone got 100, but there's a person who just gets 0 somehow, and the mean would be just like be struck down so much. But median is not. Median is like the middle number. If people have a really high score, it's not going to like influence the other scores because it's like the middle value. It's like just you like order everything from the smallest to the largest, and it just counts like if we have a 24 value, then if we have 3 value, then the value is 2. So if we have 4 value, then the median value is between 2 and 3. So as a result, if we have 24 values, then the value should be between 12 and 13. Or like if we have 25 values, then the value should be like 13. So that's the median. And then when you describe about the center, you have described that the median is at like the median is what value, or like if it's a histogram, then you describe that the median is between 10 to like probably, I don't know, like probably like you will describe it. For this, you might need to like just see the percent to determine, but now I would not like just see the percent. So probably you will describe like the median is between like 7.5 to 10 if it's a histogram. And if it's like you have the real value, then you just tell people the real value. And if sometimes also like you describe that by mean, it's also fine, but it just depends on the situation. After S, like S the shape and O the outlier, and C the center, the last is spread. So spread is mostly describes the range. So for this, like the range is like from 0 to 22.5, and you can also like say like also you can say like it's the range is like 22.5 minus 0 equals to 22.5. So the range, for like most of the time, if people want to describe that detailedly, people will both like describe the start point and the end point, and also describe the like the true range, like how do you say, like a range with minimum and maximum. Sometimes people would just describe like the length of that value, but sometimes people would describe 2 points. And that's like basically how you are going to like describe a shape. So basically shape, and then outliers and center, and last spread. Some other about like statistic is probably not so related to us. So some other basic knowledge about statistics is mostly like for design studies. This is about like you want to how to like first like you need to like consider the bias. If you like get all the data from people who just came out of library, but you want to describe the whole study, it's like the confounding variables is probably like the people like who read a lot is probably people who is likely to get a like a higher like level of education, or the person is like passionate about study, and that's not gonna be accurate. That is called like a convenience sample. And that's we can also like see this. So I think I have also like write that in my notes. The way in my notes is like much more detailed. Voluntary response sample is like you just give a poll, give a survey. Some people like return that, some people does not return that. So basically, if you have like a singer who asks like, do you like my song? And most people who answer, so like the people who answer like the song is probably like like higher than the people who really like the sound of like the overall population, because if only like if you love that singer, probably like you will fill out that survey. And random sampling is just like random sampling is what we usually do. So that's like the correct way. You just pick people randomly with like try their best to like reduce the bias. Simple random sample it's just like random sample. It's like the way that we usually do. So sometimes like we just label each. So for example, if we want to like sample about in our class, like how many people. If we have a class which is like 1,000 people, which we probably cannot like ask each one. So we just like label. We put every person in this class like in alphabetic order, and then we label the person from 1 to 1,000. And then what we do is that we use a random number generator. You can just use like numpy random dots RANDN, which we have talked about like yesterday, like to get for example, like to get 50 unique number, and select the people with the corresponding label number as a sample. That's like the simple random sample. Also, like we have other methods. So stratified random sample is basically like we have people from like 9th grade, 10th grade, 11th grade, and 12th grade. So stratified sample is you already divide them into like 9th grade and 10th grade and 11th grade and 12th grade, and you just pick people. You just like pick. For example, we have how many people? We have like 20 people from a grade. So what we're going to do is probably we're going to like pick 4 people from each grade, because we wait a second. So we have 200 people. Okay, we have actually 200 people for a grade. So we are going to probably like, take 40 people. It's reasonable. So we're going to take 40 people from each grade. That's like the stratified sample. Or like stratified sample probably does not mean like equal number of people from each grade, because here like we have equal number of people in each grade, so that's the reason. But if we have 1,000 people in 9th grade, we have 800 people in 10th grade, and 600 people in 11th grade, and probably like 400 people in 12th grade. Now we can what we can do in stratified sample is that we can take like 100 people in 9th grade, or like 100 people in 9th grade, and then 100 people in 9th grade, and 80 people in 10th grade, and then 60 people in 11th grade, and 40 people in 12th grade. So the proportion of like the sample that you take from each strata, so or stratum is for like the singularly form, strata is like the plural form. So from each strata is proportional to like the population of that stratum. And also another way is cluster sample. So cluster sample is like cluster sample just take from like the same place. So strata sample is, for example, like we have a company, and the company have like 4 people. Company have a 4 company in Europe, and 20 company in America, like from like North America, probably like. And then you take probably like 8 company from them. So that's like stratified sample, but it's not like if you have like already separated like US and Europe company, and you take like the proportion of US company from like other people in US. So so basically strata, if like it's stratified sampling, it's similar between each like individual sample, but different from each group. And for cluster sample is similar from like each different sample, but like different between each single pieces of sample like that. So it's like think about like similar between, different from, or like similar from, different between. That's the way like to really like remember stratified sample and cluster sample. And basically cluster sample is more convenient because if you just take like 8 company without like selecting few people from each company, that's like more convenient. You just need 1 people probably fly to that company and do the research. You don't need like give like 8 people from this company, 8 people from other company, 10 people from the other company, give them tickets, let them like all continue or something like that. It's like convenient, but the problem of cluster sample is the cluster that you choose might have some problems. So probably the cluster you choose have 2 minute 12th grade. Probably the class you choose is like a excellent class, like a fast-paced class, and people are in that is really great. Or probably like when you choose company, it happens to like all the company that you choose is from like US or something. That can be problematic, not really representative. The problem for stratified sample is it can be like so difficult to take them. You can like just like if you like let this single line people like just this line of people just like came out. Like sometimes it can still be like easier, but it's like if you have like a football football competition, if you like take clusters, I will probably just choose like some people who sit together. That can be biased because they come from like a family or something, a company or a school. But you can just like let them just came out from like the seats, like came out. It's like easy. But if you like select people randomly from like all the corner of the football like football stadium, it can be really not so convenient. You need like these people need to stand up. The person need to ask the people next to him or her, like, you need to like give me some place. I need to walk past this land. So it's like difficult. And also like for the basic statistics, you will also like know about like probability. You talk about like binomial and geometric distribution. So binomial distribution, or like it's basically if we like have like it's like if you have a like stack of cards, like how many what's the probability that you always like have this stack of cards, you always like put it back and you will like reorder the stack again and again. So what's the probability that you'll go like 4 times the hearts, or like at least 4 cards are hearts if you take 5 times. So the times is fixed, but for geometric distribution, the time that you like do something is not fixed. It's like how many times you need until you succeed something for once. That's like geometric distribution. And also like you know about test and also confidence level. So that's some way for us to predict about the population, or predict about something that we have not have like enough information about. And test is just basically about whether these things can be true or not. Do we have like enough evidence that it is true, or we can like probably confidently reject that this is not true. So that's a test. That's a chi-square test. Chi-square test is really like useful for biology, for the alphabet. Like also like all those tests are important like for most science subjects, because for also like p-value, I don't know like have you like read like the COVID people like talk about the effectiveness of vaccine, or like when they talk about like what's the probability for a certain group of people like got COVID, people have like mentioned a lot about like p-value. So basically just it's showing like whether this experiment has been like relatively more believable, or like the result can be likely to be more correct or not. So yeah, so that's like the basic part of the statistics, but it's basically like the least regression line. It's like really important for us. And then I'm going to briefly talk about like some basic concept of machine learning first, and then if we have time, probably like demonstrate the coding part. But if we do not have time, I'm going to put everything in Notion. And I feel like actually machine learning part is actually easier for reading the document to learn them by yourself, and especially like after learning with NumPy and others. So wait, I need to like refer to my notes, which I refer to my note about machine learning. So yeah, so basically I'm first like talk about like the relationship between AI and machine learning and also deep learning. So AI uses machine learning. A branch of machine learning is deep learning. So deep learning is like really like heavily involved in like neural networks. And machine learning like, and also like the use of like machine learning, deep learning. The most of it is for like classification. It has like a categorization or like classification that has been like mostly used. So what people do is like probably fraud detection. Probably like we have an email, and like machine learning can help you like to determine this email is a spam or not. And you need like a training set, and you have like the test set, and it has a value that you really get in. So training sets is probably like about like 7% of the data, and like the test set is about like 30%. And also like machine learning is for like web search results. So it like automatically determine is that the category that you really want. For me, I study astrophysics. My intended major is astrophysics, so mostly machine learning is for like determining what's machine learning or deep learning, mostly for like classify the graphs, which would take about like we take images of the sky. So determine like what kind of like astronomical events that really is. So is that a binary? Is that a variable star, or is that a micro-lensing event? Probably that becoming too technical, but it's basically about like what the image is really about, or like what are some like deflects in the camera really about. So yeah, is that like a wait, that might be too technical. I know I can discuss about that, but it's basically like, is that a camera deflects, or is that a deflects in data reduction, or is that not a deflux? Is that really a like events happening in sky, really not because our camera have like some problem? So also like when like the computer just recommends different things for you, it's like need to like categorize itself, whether like if we want to get education information, is that really for education, or just have like education keyword, but it's actually a like something like talk about like social policy. And so yeah, that's basically the most used. And for the process of machine learning is basically first like data acquisition, and then it's data cleaning. So you need to like first like delete something that's not like really good example, and then you need to have the test data. And test data is for you like to find like which model just like be most useful, or like just know like sometimes it can like help you to determine how many categories that you really need. And then you need like the test model to test like whether test data to test like whether this is like truly something that is good to use, or like just our is that like our so like is that our training data just have like some problem? And for the machine learning, we have like mostly two types. So like the first is like we have like supervised and unsupervised. So supervised is the one that like we have like 5 categories. We have 10 categories. We're going to put something into each of the like category. The unsupervised one is mostly you don't know how many categories there will be. There might be time that might 100, there will be 200. You just wait to like see the answer. And machine learning can actually something that I see before is that also like it can use like to categorize the disease or something like that. So yeah, that's like really great. And also when you like have the first like learning, then you need like reinforcement learning. So it's like the algorithm needs to like discovers through like try and error to determine like which action really yields the greatest words. And so machine learning, like we have a so for like first like mostly the basics I have like talked about these square these square like regression line, and that's like just category, like it just like this just tells us like a tendency. And for more like you can like determine like are you going to use different like polynomial line, which kind of polynomial. And then if you go to go that more deep, you have different algorithm. You have like support it's called support vector machine, and you have like random forest algorithms. So I was like kind of like involved in random forest algorithm before in one of my research. And then you go to deep learning, you have like neural networks. I think people have mentioned neural networks a lot. And also like the like KNN. So KNN is just K nearest neighbors. That has also been like used a lot. And something that I haven't talked about in when I like talk about statistics, I should talk about it. It's about like accuracy and precision. I can just Google to show the what's accuracy. I think it has a graph which is about like accuracy and precision, which is pretty much good. I can't find it. So basically, so sometimes you need to like determine what the like accuracy and precision, like which do you prioritize, and also like when like the accuracy is just so bad, you're going to like reject that, or like so it's like accuracy and just precision is not like it's like doesn't mean like the same thing. It's about like so basically it's like one of them is about like the data just clustered, the data cluster together, and that means like you have like a high accuracy, high precision, and the data just clustered together. Like, but high accuracy is like if the data just like stay like close to the true value, but probably can be like so scattered or something like that. And so I'm going to like show some package of machine learning. So I'm going to shift to my IDE. So this is my IDE. So right, this is my IDE. Okay, I've already write something here. So the first is just sklearn, but sklearn have a lot of different package, and also another one just SciPy. Sometimes it can also like help. NumPy can help, and Pandas can help. Pandas can help you get the data, and after you get that, you really need to like use sklearn, or you need to like use and sklearn has a documentation which I send out later, and also I just found a book which is kind of like useful. I'm going to send that into the chat. So wait, can you open in this way? I don't know if you can open in this way. If you cannot, I'm going to like send the direct link for that. But yeah, basically that's a book that I found like pretty much useful. Before I get to, probably I will send it later. So I have like talked about before, if I want to like find data, just go to like data.gov. It has like a lot of different data. If you like just specifically on the try out that some data, but don't really have an idea like what kind of data do you want to get. And then I'm going to show you like the basic use of my IDE. I'm going to move this bar to another place. Okay, this is better. So the first, I think I have just written here. Okay, so yeah. So since I've already written here, we're just going to run that. So first you need to install sklearn, then you need to employ linear model. Basically means that what we are going to like approximate to is a line, is a straight line. So this is like the data set what we put in. So basically you need to like put the x value and also like you put the y value. Wait, where is it? And you also need to like put like dimension of it. So then wait, it just stuck here. Okay. You need to put point and then you need to put like the dimension of that. And fit is just like you let this like model to like fit in the data that you have put in, and then you can print out them. So this is just not going to, okay, my ID just stuck here today. It's just super slow. I don't know why. Okay, I have actually already run that. Then wait, why this is just, okay, sorry about it. It just became so slow today. Yeah. So basically, this is just going to give you linear regression, and this is going to give you like the coefficients of linear regression. So here, like we get a array for like 5 and 5. So that's like the 0.5 and 0.5. This is the regression line for this. Wait, is that running? This is, my laptop just becoming really slow today. Probably I'm just going to talk. I'm going to like sound the link to those methods later. Probably I'm just going to like hold another workshop to talk about that because my laptop is just sincerely so slow today. So basically you have like the linear regression, and that you also have like ridge regression. And for the ridge regression, it's not like linear model dot, it's not like linear dot model dot linear regression here. You can do like linear regression dot ridge. And it's kind of hard to like explain what the equation is because probably a lot of them has like related to like statistics that probably we like love us haven't really been learned before. I don't know, it's like also like you have like the lasso linear model. So what you're going to do is you're going to do like linear model or lasso. I will send the documentation about like what's the difference between them later. And also the lasso can be multitask. You can like describe about like different like you have like different set of data. You can have like different description. You can also have like elastic nets. You can have least angle regression. All of them, like what you're going to do if it's like least lasso, like you just linear model or lasso. And if it's like linear like loss lasso, linear model or lasso lars. I think I'm sorry. I'm really sorry that my ID like become like super slow now. I don't know why. Like I don't really know why. Like everything just become really slow. So basically, if you have like a data from a website, like from like a website, what you can do, it just becomes. So basically, you're going to like if you like get data, so you import panda as PD, and then you kind of create a data frame. Like by creating a data frame, like you first need to like read the data. So just like I told yesterday, if you download data from like data.gov, you mostly can see whether in like CSV or in JSON. So read CSV, and then parentheses, and in the parentheses just put the file name, any file name, like if you get that, and then like for the x value, it's going to equals to like df, like probably you're going to, like I talked yesterday about data frame, you're going to like slice or like get the data from the certain certain like column, and also like you're going to get the y value, and you're going to call that from like another column. You're going to put the name in it, and after that, what you can do is that you can just do like regret, like you can write like regret equal to linear model dot like linear regression, and then you can do regret feeds. In regret feeds, you don't need to put all of this. What you can do is just regret feed, and then put the x value, and then put the y value, and then you can like predict the value. So you can predict that, like you can like predict like y hats. I don't know like what we're going to call that now, so probably just predict y hats, and then you just write regret, like, and then what you're going to write is just predict. So regret predicts. And in this parenthesis, what you're going to put is probably like predict the x value. So x value, if you give one variable in that, so wait, if it's one variable, then just go probably like this name is called from like A column, this is B column, and predict like one you predict like a value which is like 30, that is like in the category of A, then you're going to get like what the value for the B is. And what we can also do is that you can read like two data, like two columns for X. So for example, you need like from like A and C data to predict like what B is. And then because like you have two data, you need to put them like first in the brackets, which is for like the data frame, and then you need like in another like list put two value, and then now here, so you can again like put a list. So because we like need to predict from two value to determine our y, so you're going to probably put like, I don't know, like 30, 45, and you're going to predict the y. So that's like the way for the basic linear regression. But linear regression is just like the most simple way for doing them. We also have we also have like polynomial regression, and it's wait. So for polynomial regression, it's just what you can do is that also you can like plot the line. If you want to like see the effects of like drawing the regression line, what you can do is that first like plot the things with your matplotlib plt dot plots, which I've talked about like yesterday, and then we want to like plot the like polynomial one, then you're just going to like, if you have the x and the y value now, and then you can still like let that equals to, you can like that equals to Rick, or like so I'm just going to comment this out. I don't have the value here now, but I'm just going to talk that. So you can also like have a model, and this model just equals to have an import numpy. So I'm going to import numpy as np, and for this model, what you're going to do is that you're going to do like np numpy, and the function that we're going to use is polyld, and then we're going to put like numpy, np, then we're going to call polyfit. Polyfit just means like polynomial fit. You're going to put like x and y, then you're going to like specify like what's like the highest what's like the highest power of the x, so probably like 3 or like 4, so mostly probably for example like 3, and then you can create a myline for that. So like we are going to just have a line or curve for that, and then you can do like just like what we have like talked before. So you can just like do numpy.link space, then you're going to talk like how many value you want, and you're going to like plot that so you can see the results. So yeah, so basically what you're going to do is like line, and the line should be like np dot link space, and you're going to like specify the start value. So I don't have like the exact start value now, so you need your start value, and you also want a end value. Then you're going to say like how many points that you are going to want to have like point number. And then what you're going to do is that you're going to like draw a scatter plot, mostly scatter plot. So just plt.scatter, which I have also like talked about like yesterday, plt.scatter. And what you're going to do is that you're going to like set your x and y, and then you can do like plt plots for our line. So plt scatter like draw this point out, but you also want the line, so plt.plot, then the line is just line here for our name, and then we are going to use our model, and our model you need to like let the model it has a parameter, and the parameter is going to be our line, and then unless you can just plt.show to show it. So that's for like our polynomial regression, how to draw that out. I'm going to send some documents later, so I think that's so much for today. Sorry for like this does not have examples, so the final part might be a little bit too abstract. Really sorry about that. Yeah, so that's basically what I'm talking about today. And if you have any questions, just feel free to ask about it. Yeah, I'm probably like going to like put an example in Notion also like later. It's so abstract of not talking with the example. Sorry for that. Okay, thank you so much. Thank you everyone for coming. Thank you like everyone for participating. It's really nice like to meet all of you, and thank you a lot. Also feel free to ask any questions. I'm going to also put some examples now. Also, like I think I have put like the question form for day 1. You can see like put question there, and you can also like suggest like what materials should I put into the Notion file later. Thank you everyone. Feel free to leave if you don't have question also. Thank you.